Okay, let's begin. Welcome back to the stream on this Monday evening. I thank you for joining me and us on this adventure as we continue this project. My YouTube viewers, thanks for checking out this video and sticking with it this long. We really appreciate that. Definitely like and subscribe. Hit that bell icon to be notified of when new videos drop, because we try to upload as often as we can. Trying to keep everything updated and going. So from the stream yesterday, the last video that we did, we pretty much completed all the testing we could with the basic subsystem. So all the subsystems worked as intended. We had to do some rework, but that's expected for first spin. We didn't have to redo another board, which was extremely helpful. So today we're going to do some designing, basically with Fusion, to get the resistive load built, so we can start working with the deep system tests, which could be more destructive testing. So let's go to the primary display. So to recall, I picked up this big heavy duty guy right here, the 200 watt 50 ohm wire wound power resistor variable, so we can get better dial in our current draw, and this guy should be able to handle it 200 watts. So it's going to be a universal piece of text fixturing that we'll be able to use. So yes, I did find my purchase history, and I did order that blue box I showed on the other stream from Amazon. So what I'm going to do is I'm going to use all these tabs, and I'll create like a bill of materials as we go for this. So it comes with the metal end plates, end caps, front and back. I'm going to just design something and print them out of 3D plastic. I'll do with PLA for now, but if I have to, it's just over to something a little bit higher temperature rating, like ABS or something. We'll see. But PLA, at least for now, and I've got a blue. It's a little darker than this. Maybe I'll go with white, but I'll go with blue. A little bit darker, but it's fine. I don't care. I won't be using the metal screws that come with it. I'll probably replace those with like nice black oxide M3s. Button heads. So that's what we'll do, even to the point to where if we have to kind of over drill the hole here and sink in M3 inserts, heat set inserts, that's not a problem. I'm not opposed to doing that with this. And same thing with the sides. It doesn't have the cover off, but the sides are kind of held on by similar screws, and I kind of want to replace those, put the nice little M3 button heads in there, the little black oxide, just to give a nice little touch, just because. So I picked up these guys, ammeters, supposedly, 0 to 10 amps. It looks like maybe down to like the 10 milliamp precision, but we'll see. I don't know. We're not really looking at that because we're actually going to be looking for more full amps, like 1 amp, 2.5 amp pulls. Just to see. Hopefully this will work. I'll have a meter in between. Will be I get double check before the final build. So what I'm going to do is I've got one of these guys. I might not leave it in here, but this will be cooling to help pull air in to keep that resistor nice and cool. So if you've noticed, so in here we've got these cooling vents on the sides already in the box. And what I'll do is I'll mount the fan. We'll 3D print a new back plate that'll mount the fan. And then also one of these guys for 12 volts coming in, because that's how we're going to power the fan and the ammeter. So this is going to be powered from 12 volts from the same supply. Run the fan. The fan is just going to run constantly. I don't care. don't need to worry about it because it's, you know, we need to make sure that that resistor stays cool. I got, you know, the nice little screws for the fan. That's that. I've got a similar power switch, you know, we'll just basically to control main power on and off. Nothing big, basically just because. And then this is what we're going to be powering it up by. Now, one of the things I forgot to throw on here is, so I'm going to be using, I've got one of these, got a kit, like a banana plug kit. And I'll start with that. Did I actually order a kit from Amazon? Hold on, let me look. I forgot to grab this. Probably did. Banana plug. I order a kit. Yeah, here we go. I'm not too thrilled over these, but I'll bring this over. So I've got a kit. Got the plugs. These are not really that great. Haven't tried these guys yet, but I'll use these to basically, you know, connect to the load. So that's what we'll be using for those. I'm going to have to run into the workshop and grab so I can get dimensions off of the binding posts, but that's not a big deal. So like I said, I'll have we'll have a bill of materials for all this just thrown in there in case you want to build one too. I mean, you know, it'll be there, be part of the project. In fact, we're going to kind of make a project out of it. And then just on a kind of a side note, before I get too far. So yeah, I couldn't find my thermocouple adapter for my meter. So I bought one. I've got one coming in, but I also found something that I also picked up one of these guys because I think it'll be a little bit better. A 4-channel thermocouple probe, basically, just for reading thermocouples. That way we can set up multiple points on the board. And this will allow me to do other things without having to switch between meters and thermocouples. So I've got this coming in too. So this will be great to use for this project as well as others moving in the future. I'm not going to count this on the project budget because this is kind of more like for my workshop. It's not just going to be used on this project. So this is kind of a side. Now this stuff, realistically, I've already had it. Except for this. I just bought this for this project. So I'll figure out, maybe I will just kind of chalk all this cost onto the project just to track it. Because I know the resistors on there. So like I said, all this will be I'll create a bill of materials. So everything's going to be done in Fusion. So the first thing we need to work on is... So what I want to do is, we'll bring this back over and just kind of like minimize it. So the resistor, we're going to have kind of the main shaft coming out the top of this guy. And I think that'll be a lot easier. For one thing, that's the only way it's really effectively going to fit in here. This thing's just way too big to fit, you know, with the shaft coming out the front. And I've already bought this box. I'm not going to buy a new box just for this project. This will work perfectly for this. So what we're going to do is we're going to measure the inside of the box, the lid. So I've got the lid off. No webcam. This is just going to be kind of, most of it's going to be done in Fusion anyway. So we're going to get Fusion going here. We're going to create a new sketch. Bump, bump, bump. So what we're going to do with this is we're going to just kind of create the top. So what I'm going to do is I'm going to create the drawing, basically, draft out all the measurements. And I'll just print this drawing, maybe export it as a DXF or something. No. Export it as a DXF and just print it to my laser printer and use it as a drill guide. And I'll take the lid to the drill box and I'll just drill the holes and ream them out and clean them up as necessary. Because all we need is a hole basically in the center of the lid that can also accommodate not only the main shaft, but also that tab, which is basically the indexing tab. So accommodate that. So we'll have to have the main shaft coming through, and then that locking tab to basically keep it from rotating in place. That's what we're going to do. The good thing is the locking tab is in line with the center tab, which is for the wiper. So that's what the wiper is tied to. So that makes things easier in trying to figure out how we want to line this up in the project box. So we'll get all that taken care of, nice and clean, easy peasy. Because the only lines we're going to use for this project, the only two things we need on this are the wiper, and then probably, see, the wiper, that'll be your center location, and then increasing resistance. We'll have to figure out where we want the probably the tab. This tab right here should be increasing resistance as we go clockwise. So that's how we're going to approach it. We can always reverse it if we want to like switch our logic, like increase resistance, or are we increasing current draw? It depends on how we want to logically look at this. So back to here. Like I said, a lot of the stuff we're going to be doing is going to be in Fusion anyway, so there's no real reason to really have a webcam and show this stuff. I've got my little ruler here. We're 240 millimeters wide. And this guy is... It's just going to be laser. It's just going to print it out in the laser cutter or the laser printer, just on a sheet of paper, and just tape it in place. We're about 160 millimeters here. All right. That makes things nice and easy. Yeah. From one program to another, it's always different. Trying to remember what buttons on my mouse do what. So we're not going to be doing any extrusion or anything. I'm not terribly worried about the diameter of that right now, but we want to center of this, which is 80 millimeters. And the center of that, 120. My goodness, look at that. Beautiful. All right. Put it there. So that is going to be the shaft. Again, we're not really worried about the diameter because I'm just going to use this as a centering. The only reason I need to worry about that is I don't want to interfere with the locking tab. I could have just thrown some lines on, so it's like 9.8, so 10 millimeter roughly. And we know the tab, the locking tab, is basically in line with the wiper. So we're going to throw this guy. It's just going to be a round hole, because it'll be covered up by the knob, so ain't no big deal. What would the diameter be? About 5 millimeters. And then center to center would be, kind of just swag this. Again, ain't got to be perfect. Looks like it's around 13 millimeters. Let's just make sure we're 120. All right. Now what I'm going to do is throw in a line. Throw a couple of lines. All right. So we're going to finish the sketch. So basically, those will be our center point. So what we can do is we can use a a punch, basically, to mark the location. Or just, like I said, it's going to be taped to the inside lid of the top. And I'll use the drill press and just carefully pull it down and drill it out. Just use the paper as the guide, just like that. So we're going to... So what we should do is, before we get too far ahead of ourselves, let's go actually create this as a project. 0119202601 dash. We'll just go and throw it as a project in here, and treat it as a project for the most part. Basically a sub project. That way we can create the BOM and everything for it, and everything be happy, and we can put all the I'll export the Fusion files. I'll export any DXFs, any STL files, and put them all in there. That way they get uploaded to the Git and you have access to them too. So we're going to call this resistor box. This is what we're going to call it. Who cares? We're going to call it, don't really need all the organization because there's no firmware, no real document. Everything's just going to get shoved together into one thing. So get that, and then we're going to file. Let's just go and create a new project. New folder. Save that folder. Lid drill mark. Lid drill marks. Okay. Okay. So I'm going to don't think I can print it from here. I think I do have to export it as file. Yeah, maybe we have to export it. All right, well, that's fine. All right. We're going to do a DXF file. I'll just throw up my downloads folder for now. Come on, computer. You're taking so long. It should not be that long to export that as a... Really? That long to export that? Okay. Just for a simple DXF file, just a couple freaking lines. Because I think we can just use any DXF viewer and then just print it out. Oh, it's complete. Okay. And drill marks. We're going to take that. We're going to throw it here in the projects. So that'll be the that'll be this. So like I said, we'll get it printed out. I'll print it out my laser printer just in black and white. Use it just to drill the holes, and I can resize them as necessary with a reamer, and not a big deal. So that's that guy. So let's go ahead and get this guy done. Yeah, I like to... Oh, gosh. All right. Yeah. So used to using the one mouse button to drag, the right button versus the middle mouse button. I might have to see about, you know, let's go and save this. So we're going to call this the front panel. So yes, I know with Fusion there's a way to combine all these objects together. Great. I don't care about that. I use Fusion Utilitarian to create files for 3D printing, and most things are just like one shots like this, like a panel or here and there. And I don't really care much to do complex 3D geometries. I'm not really, it's not really necessary for the way I use my 3D printer. And when I do need a complex 3D geometry, I use Blender for that. But when I'm doing things like this, I don't really need the complexity. And I've come with learn the simple principles. You just keep it simple. Keep everything simple. So let's get this guy measured out. It'll probably be a little bit wrong. So 233. Yeah, 233 millimeters by looks like about 95 millimeters. Oops. Helped if I'm actually. Okay. Now, let's go ahead and we're going to go and throw in the. And yes, I know Fusion has a whole bunch of things to line things up better, but again, never took any classes. So we're going to, like I said, we're going to do M3. So we're just going to go and draw them out for 3 millimeters. But let's go in 3.125. Let's kind of increase it just a hair to account for shrinkage. Now let's get our dimensions. So that is approximately, so I'm coming off the measurement off of the actual front panel. It's like 4.3, but probably 4.3. Yeah, 4.3. We may have to print a couple of these before we get it right, but not a big. Let's get this guy. Odd measurement, but might be, like I said, might be a little bit off, but we'll deal with that if we need to. We got plenty of filament if we have to print out more than one of these to get it right. Perfect. Now, so I take care of the mounting holes. Now we have the, let's see, this is front panel. So we have the, we're going to have this guy. We got to get mounted. We have these guys to get mounted. And this guy to get mounted. So, figure kind of over here. We'll have the panel meter. Down in here, we'll have the banana plugs, and then over here, we'll just have kind of like the power switch. So I figure that's how we can do it. So let's throw a square in here. Let's get its dimensions. Not going to be, this is easy to grab with this guy. Let's go a little bit bigger, 45.25. We can always use a deburring tool or something similar, like hobby files or something, to clean it out, open it up a little bit if we have to. So that's about 26. That's actually makes things a little easier. All right. I'll figure out how far down we want it. 20 millimeter. The reason I can't really put the center is I'm afraid it'll bump into the resistor. And it's mainly going to be for reference. So that should be fine. Maybe. Let's see. Let me see. We might actually be able to put it center. Hold on here. Oh, okay. I was worried about nothing. Plenty of room to put it more center to the unit. Okay. I was worried about nothing. All right, so let's go to 25 from the top because we can put the banana plugs under it. Let's see here. So, all right. Great, doing complex math. This is not my forte. Okay, so then we need to do that. And now we also need to bring it back over a little bit. I should have popped it right in the middle. Okay. We're just playing around here. 2.625. Could have just thrown like a construction line, did the same thing, but 22.65, perfect. Yeah, so one of the things about Fusion is you can throw those formulas in there and do math directly in your dimensions, and let it calculate everything out for you. One of the things I really love about it. So let's go ahead and throw in the hole here. So it's just a hole. This one doesn't even have a flat spot on it for indexing. So it's approximately 18.65. 18.65. All right. That's going to be for the power switch. Let's go 35. Yeah, let's say 15. All right, now give me 2 seconds. I need to go grab the banana plugs. Completely forgot to grab those because I need to get the dimensions off the shafts. All right. So let's grab one of these little guys out. Yeah, it looks like an M4 stud, to be honest, but probably is. Yep. It's not exactly M4. Only 3.65. Huh, interesting. So we're going to do draw 2 little circles. Equal. All right. Give them that. Let's get them some distance from each other. Yeah. Let's see how big the actual bodies are. 40 millimeters. Let's say they're 11. So side by side, they're about 12, so it'd be about 24 millimeters. So yeah, 40 millimeters might be a good distance between them. One's going to be red, one's going to be black. So So let's, their position from the bottom isn't too bad. So we'll leave it at that. Sometimes they like to move around on us. So now we're going to do another one. Those fancy map. No. So we're going to do, all right, 2 minus, well, we already know this can be 20 times 1. And that should put those guys center below this guy. Yeah, I love being able to throw math formulas into the dimensionals, especially because math is not my forte. Math is I'm not good at math. So that'll do mounting. We have the ammeter, the binding posts, and the switch. That's all we need for the front. So now we got to work on thickness. Let's see here. 2.5 millimeter should be sufficient for this. Now, one of the things we're going to do, something I've learned with any enclosure, grab the corners. We're going to put a slight little chamfer on them. 1 millimeter looks like. It'd be maybe noticeable, maybe not. What I've learned is sometimes with the square corners, things have a hard time fitting into where they're supposed to go. And I find just putting a little chamfer that might be, too much. We can drop that down to 0.5. There we go. Save. It takes off that corner, kind of, for lack of a better term, smooths it out a little bit. And I've noticed that lids fit better just by chunking off just a little bit. Because, the 3D printer, the way that it slices and interprets everything. So one of the things we're going to kind of do too is the panel meter should just snap in there. Again, we can kind of clean it up with files or whatever. Any of these holes, like especially the mounting holes and the binding posts, we can use a reamer, kind of clean them up with, or drill bits or whatever. So I say that's good. I'm going to resistor box, front panel. Then we're going to 3D print it. Okay. We're going to save my downloads. Bamboo Studio. Might as well go and get it printing. Might as well, right? And I'll go ahead and, once I'm done, I'll go ahead and also save the 3MF file, the Bamboo Studio file, to the resources, to that same folder. That way, if you've got a Bamboo, you can go ahead and there. We're going to add only 2 plates, but let's first get all this crap. Let's use PLA Basic, use blue. Huh. Okay, it's not showing the weight. I don't know why, but jack the temperature up. Okay, so grab the front. Oh, maybe we could do the back as well. Clone. One clone. Let's see if it'll auto Oh, I can't do the back as well. So I'm not going to print it yet. Okay. So we're going to save this. Now we're going to kind of cheese wheel ourselves. File. We're going to save this as back panel. Kind of grab here and back panel. Okay. Why not cheese ourselves? We go through here, and all we have to do is adjust the sketch. We already have our mounting holes. We've got our dimensions already there. All we have to do is get rid of this guy, get rid of the binding posts, and let's see here. We can just kind of update this hole for the wire connection, the power connection. So it's like around 12.37. All right. Okay, we can keep that. All right. And now the biggest thing to worry about is the fan. So one of the things I did was I went and grabbed the data sheet for a fan that had the same dimensions. The 80 millimeter size is pretty much a standard size. The computer fans, they're no different. 80 millimeters is the external dimensions. So I wanted to just get the screw holes. And heck, it even shows like the dimensions of the hole itself. We're going to go a little bit bigger through the plastic, but it gives the dimension of the actual fan and the holes. So, like I said, I just grabbed that for reference. I'm going to drag it off my screen because, like I said, we're probably going to put the fan like right in here. It probably fit behind the resistor, to be honest. Let me kind of not throw things around at myself in my office here. Grab the resistor, kind of put it in the middle. See how the fan... Oh, that would actually sit there. Okay. I mean, that might actually be more beneficial, especially if we're pulling air in. Okay. All right. Well, that's what we're going to do. So we're going to set it in the middle. No deleting, please. So we're going to, first of all, get our holes set up here. Right. Equal them. Dimension. So like I said, the drawing gives us about a dimension, diameter about 4.5. So we're going to kind of go 4.8. Again, we can over drill them, use a reamer to clean them out. Or I could actually do the right thing because I have them right in front of me. Because we don't need it binding into this cover because they're going to thread form into the fan itself. So I don't really need to worry about it binding. Okay, so their size, they're actually measuring about 5.15. So let's go 5.2. There we go. That way we don't have to worry about them binding or driving into the plastic back panel. Now we're going to get our dimensions here. We're going to put these guys. So 71.5. So one of the things I've noticed, not that I'm complaining. All right. Okay. So we should be able to use the same tricks. So it's going to be 233. It's going to be 233 divided by 2. minus 71.5 divided by 2 times 1 millimeter. And that should put that center. And then we're going to do the same trick for up here. It's 95 by 2 minus so now that should center the fan. Okay, so now we got the fan and now we need some air holes. Now we could do this in a couple of different ways, to be honest. So one of the things we can do is we can just throw slots in here, a couple of slots or holes. We can do some fancy stuff with like concentric circles. So let's try that. I don't know how well this will work. So let's get this guy centered. Get this guy centered in here first. Get this guy. Okay. So now we have it centered. And let's kind of come out to here. I don't know how this is going to work. So what we can do is throw this guy in here. Let's go 75. All right. Yeah, I'll show you what we're going to do. So let's throw a couple more circles in there. Five. Let's see, 65 to 75 is 10, so 45. Let's create another pair of circles. So that's 45, that's 35. All right, let's try. It's gonna be kind of weird, but D off the center. Like I said, I don't know how well this is going to work, but we're going to try it. All right. It's going to complain. I don't care. It's not going to hurt anything. All right. So all right. So, okay. So I might have to fix that extrusion. Let's see what this looks like. So good. Extrusion. No, I might need to fix that sketch. Hold on here. Oh yeah. Let's get that trimmed. Don't forget this stuff. Get this guy out of here. Okay. Oh. No. All right. All right. Let's go here. We'll have to put that chamfer back in there, but that's fine. So grab this. Grab this. Or grab this one and this one. Ah, this one and this one. Nope, that one. All right. Nice at 2.5. There we go. Not the neatest. To put the chamfer in there. Millimeter. Okay, now, so I want to maybe do. Okay, so let us. Computer's not happy. It doesn't like doing things like this, but that's fine. Correction. Fusion doesn't like doing things like this. It doesn't like working the way I. So we're going to. We're going to kind of smooth that out a little bit. How's to look? All right. That way, we're going to pull air in, I think. No, maybe we should push air out. Which would mean the that would be going on the inside, which would be fine. And it's fine if this guy gets put on the right or left side. I don't really care. That way it kind of cleans that up. I really don't know. Maybe I'll pull air in from the outside. And And I'll do this. Yeah, let's just pull air in from the outside. So let's get these guys. Jumper. Be a little too big for the screws. Let's see, can I get 10.2 millimeter? Let me get the screws diameter. 10.2. That might be too big for this screw. Basically, just so we can countersink it. 6.18. So 2. 2. 5. That's fine. We don't want to go too little. That way the screws, because of their shape, they're basically what they call flatheads. So, or flush heads. Yeah. So that shape, they have that like bevel. That way they kind of sit flush. That way I did that. All right. Okay, those holes are there. That's there. Smack, smack. Okay. Resistor BX back panel. Right. Resistor box back. Okay, now we're going to grab that file, 3D print. Okay, shoot it out to my downloads directory. Here to Bamboo Studio. And back panel. Range objects. Oh, all right. So let's see here. Support. Don't need the tree, but what I want is a brim. I don't really support that. Others. Brim. We're gonna do an outer brim. Because of the size, they might curl up and break, so I'm hoping the brim helps hold them in place. Let's see here. Let's see if it... Okay, good. That's fine. Oh, where are you failing the boundaries? Oh. All right. Let's see if we can get that down. We can not have that failure. I think it's mad because it wants to hit here. I think it would no matter how I did it. So let's see if I can get that down. Yeah. So, yep, I think because it wants to hit this spot and it doesn't like, that should be okay. So we're going to shoot that over to the 3D printer. 2 hours, 6 minutes. It'll be perfect because should be done. And then hopefully the next video will be us assembling it. I might go ahead and pop the holes in the top with that sheet because my drill press is in a slightly hard to get to location. That way it's not causing us any problems. Hopefully, like I said, I'll get these off the printer, kind of see how things fit in there. Then maybe the next stream is, hopefully the next stream is we actually assemble this because there's a few things. Minimize this. So like I said, this guy. So it's got the wiring. So we're going to have independent power supplies because we're going to be loading it. So this is so this would be the input power supply that drives it. I think we're not sharing. So we're going to have independent power supplies basically because the load so this is how it's going to be wired. So this input power supply on the red, the small red and the small black, that is to actually power the meter itself. That's going to come off the 12 volt. The yellow lead is your voltage tap, your voltage sense tap for the load. So that's what you'll get your voltage reading from. And then the heavier black and red wires are the actual current from the power supply output to your load. So we'll get it all figured out. Basically, this meter is going in series with basically in series of the power supply, positive and negative. So basically, that's what we're doing. So yeah, we'll have that come in and get all that taken care of. So we will get this thing built up next video stream. Thanks for hanging out with us and checking out our videos. Hopefully the two 3D printed parts work fine and we don't have to touch them up. But if we have to, we have to, and hopefully it'll just be a small touch up to save time. If I have to touch anything up, if anything is going to be touched up on those guys, it's going to be, this should be fine. The fan should fit fine. It's going to be the front for that panel. If anything's not going to fit right, it's going to be that panel. But like I said, I'd be able to use like a deburring tool or some files or something to clean that up, and we can force the little booger in there. The other problem might be these mounting holes. They may not line up perfectly, but we will see. We will see. So she's printing, and it's got 2 hours, 5 minutes. All right, well, thanks for hanging out. Thanks for checking this video, and we will catch you in the next one. Have a good evening.